Hi everyone, we're looking at homework 7.3 and we're trying to figure out patterns within circuits. So I figured I'd make a video to help you guys figure out how these work. Okay, so to figure out current, even though we know electrons flow from the negative terminal to the battery to the positive, you'll see that I've labeled current going from positive to negative. This is what's called conventional current. Conventional current goes from positive to negative, and convention because that's what we agreed on. Convention means things that adhere to social norms. So, because electric field goes from positive to negative, conventional current is drawn from positive around the circuit back to the negative terminal of the battery. Okay, so then which has the same current as the battery? Trace this with your finger. The conventional current that leaves the battery all flows through the 80 ohm resistor. Both the 50 and the 100 occur after a junction. And since they occur after a junction, each takes a portion of the current, the flow of electrons, but not the whole thing. Okay, the 50 and the 100 have the same voltage drop as each other because they're in parallel. I tend to circle things in parallel so that we can identify that they're the same voltage drop. Oh, and going back to current, the 80 has more current than the 50 because imagine if 100 amps go in, some go to the 50 and some go to 100, so the 50 must have less than the original incoming current. 80 has the same current as the battery and more current than either the 50 or the 100. Next, things that are in series have the same current as each other. So I'm going to circle in blue for series, green in parallel. Hopefully you'll be able to tell them apart from the video. But in this case, we've got the 2 and the 1 have the same current as each other because they're in series. The 5 and the 1 have the same current as each other because they're in series. The nodes are circled on this diagram already. And that means when electrons leave the battery and reach the junction between the 2 and the 5 over here, more will go to the 2 ohm resistor because it's easier to get through. The lower the resistance, the easier for electrons to get through. So when given the choice at a junction, more current will go to the easier resistor. And this might seem like it's not always true. In the very next question, the 4 ohm resistor has more current. But that's because the current that leaves the 1 ohm resistors recombine to the 4. Things that are in series with the battery, like the 4 ohm with the 12 volt, have more current. 4 has 100% of the current, and each one of these paths has less. Similarly, in this problem, the same voltage drop as each other, those are going to be things in parallel. Things in parallel have the same voltage drop as each other. Things in series have the same current as each other. Between the 6 and the 4, there's more current in the 4 ohm resistor because this is after the junction. And there's more current in the 6 ohm resistor because it has less resistance, more current. When electrons enter this junction, more of them will go into the 6 ohm resistor because it's the easier path. Finally, for the front page, one pair of resistors that has the same current as the battery would be the R1 and R5. So this battery doesn't label which is positive and which is negative, so I can't label the conventional current in this one. I'm just going to make it go clockwise like the other problems. But R5, the battery, and R1 are all in series with each other, so they would have the same current. R3 and R4 are in series with each other. Notice there's no junction. I can draw a line from 3 to 4 without crossing any of those junctions. they have the same current as each other, but less than what comes out of the battery because they are after the junction. And last one on our page, when given the choice between going through the 25 and the 60, more electrons are going to the 25 because it just came out of the battery and hasn't split up. The 25 is before the junction, and the 60 is after. The front page had us practice 3 out of 4 of the circuit pattern rules. The fourth one is harder to practice, so we practice this one separately in the next 2 problems. This is the loop or path rule, and it says that along any closed path, the energy that goes in, which is proportional to the voltage, is equal to the sum of the voltages out. So in this case, if 120 volts goes in and 80 get used up by the first battery, 40 must be used up by the next one. Similarly, if 12 volts is put into the circuit and these 2 batteries use up 7 of them, then this one must use up 5. What this practically looks like is a little bit more tricky though. I'm going to skip number 1 for a sec. We're going to go to the second one because it means along any closed path. So let's make this green closed path here. We know the battery puts in 60 volts. It says so in the Circuit Sudoku of the problem. The battery puts in 60 volts. R2 uses up 26 of them. In order to complete that circuit then, R1 must have used up 60 minus 26. So R1 used up 34. But since it has to be the same for both loops, or any loop that starts and ends at the battery, let's take the outer purple loop here. That's why it's called the loop rule. 60 volts get put out by the battery. R3 uses up 15 of those volts. That leaves R4 must have used up the remaining 45. That means for complex circuits, you might not get 34 plus 26 plus 15 plus 45 equals 60. It's because along one purple path, these 2 add to 60. And along the green path, these 2 add to 60. And they both add to 60 independently. Okay, so let's go back and solve that problem now that we've clarified the loop rule a little bit. For the rest of the problems on the back page then, we're going to use a combination of the 4 circuit patterns and Ohm's law. So, in problem number 1, the easiest thing I can do is solve for Ohm's law. Voltage is equal to current times resistance, therefore 9 divided by 450 should give me the current. Now, notice that the current that leaves the battery, so conventional current going from positive to negative, the current that leaves the battery travels through R1. So this must also have 0.02 amps. That same current goes through R2. That same current goes through R3. And oh my gosh, we have solved this problem. Multiplying across the rows, this leaves a voltage of 2, a voltage of 6, a voltage of 1. And let's just double check loop rule for fun. The voltage that put in was 9 volts. R1 used up 2, R2 used up 6, R3 used up 1. 9 volts total. We're good. Okay. We already used loop rule in this problem. Now let's use the current rules. R1 and R2 are in series with each other. This means they have the same current as each other. R3 and R4 are the same current as each other as well. And multiplying across, or dividing across the rows at this point, gives us our missing resistances. So 17, 13, 5, 15. Don't mess with this bottom corner. The only way to solve for the bottom corner for now is to multiply across the rows. You can't just add them up. It does not always work. It coincidentally worked for number 1, but won't always. So we need to find the total current. So what I'm going to do is I want you to zoom in and picture this junction right here. At that junction right there, we're trying to find the current that comes from the battery. 2 amps went through R1 and R2, so that's 2 amps here. 3 amps went through R3 and R4. And so my current from the battery isn't 10, it's 5. And dividing across the row, 60 divided by 5 equals 12. So let's do the last one. And we're going to use all combinations of things. R3 and R4 are in parallel, and since they're in parallel, they have the same voltage as each other. R1, R2, and the battery are in series with each other, so they must have all the same current. If R2 has a current of 5, that same current must have left the battery and also gone through R1. So we can multiply across here. So that's 20. 50 divided by 5 is 10. 10 divided by 1 is 10. Almost done. Now, loop rule. 50 volts got supplied by the battery. 20 were used by R1. Some number were used by R2. I don't know how many, so I'm going to leave that as a blank. And now it doesn't matter what path I take, whether I go over 3 or 4. As long as this path leaves the battery, goes through one of them, and comes back, you'll still get the same answer. V3 uses up 10 volts, so 50 is equal to 20 plus something plus 10. That number is 20. That leaves us enough information to solve almost the whole problem. Last rule, junction rule. I'm going to zoom in right on this junction right here. I don't know how many amps of current went through R3, but I do know that 1 amp went to R4, and that going into this junction was 5. And that's math I can totally do in my head. 5 amps came in, 1 went on this path, 4 went on this path to make 4 and 2.5. On Monday, we will practice this much, much more. Thanks for watching.